So we've talked about adding, subtracting, multiplying, and dividing functions and the symbols for that. So there is something else that we can do with functions that we can't do with numbers, and that's called composition. So you might remember first semester, if I gave you a function like x squared plus 3x plus 2, and I asked you to find f of a plus 3, that would mean replace all the x's with a plus 3's. And remember, we have to FOIL that out. And then combine like terms. And you get something that looks like this, right? Now, composition of functions is something very similar to this process. Basically, a composition of functions means you are plugging one function into another. And a composition has its own special symbol. It's this open circle, and this is pronounced out loud as f of g of x. This little symbol right here basically means I write it like this, f of g of x. Now, if I had written g of f of x, then that would mean g of f of x. Now, what does that mean? Well, that means basically anytime I have a composition symbol, I'm going to be plugging one function into another. So let me show you how this works. First of all, let's start with these examples here. This is f of g of 5. So the very first thing I'm going to do is write f of g of 5 like that. And then whenever you're actually working with a function, you know how you normally take the number inside and plug it into the function? That's how compositions work as well. You start with a thing on the inside, and you're going to work your way out. So I'm going to start by plugging 5 into g. So when I do that, g was x cubed plus 1, so that would be 5 cubed plus 1. And 5 cubed plus 1 is 126. So then I'm going to take that number, 126, and I'm going to plug it into f. Well, f is 3x minus 6. So I believe that's 378 minus 6. So 372. Now, the second example here, g of f of 5, again, the first thing I'm going to do is write it like that. And I'm going to work from the inside out. So this time 5 will go into f first. So that means it gets plugged into 3x minus 6. And that will be 15 minus 6, which is 9. And then that 9 gets plugged into g. Nine cubed is, I think, 729. Now, notice that when we did f of g of 5 and we did g of f of 5, we got two different answers. So this means order matters in this composition. Since order matters in composition, matters which thing comes first, it's not like addition or multiplication where you just sort of flip things around. It's more like subtraction and division where it matters the order in which you write it. So we would say that this is not commutative, because commutative property means you can just flip the order around. So composition, basically, you start with a number on the inside, you plug it into this function first, and you take that result and you plug it into the previous function. So let's look at these examples down here at the bottom. So I'm going to find f of g of x and g of f of x. I'm going to do part B first because I think that's an easier one to understand. So if I wanted to find f of g of x, the first thing I would do is rewrite it. Now we start with the x, and we're going to plug that into g of x. So literally g of x is x minus 6. And then that x minus 6 gets plugged into f for the x. Multiply that out. And that would be f of g of x. For g of f of x, similar process. But again, you start with x, you plug it into f first. So that means you do x squared plus 2 first. And then x squared plus 2 gets plugged into g, replacing the x there. So that's how you do it when you have equations. Now when you have function, like written out discrete functions, like the one that's example A, the process goes a little differently. So let me show you how that works. 2a. So we're going to start with f of g of x. Now f of g of x means I want to take every value of x that is in g. This 4, this 2, this 9, and this 3. And I want to send them through the same process I just went through. So let's see. If I want to find f of g of 4, g of 4 is 3. So then I want to plug 3 into f. So I look at f and I say, okay, 3 is here, f sends 3 to -2. So I'm basically going to do that for every single x value that's in g. So I'm going to do it with 2. G of 2 is -1. Then I come over to f and say, where's -1? And plug that in, and that gives me -5. Now I'm going to do 9. G of 9 is 4. Come over to f, look for 4, and f of 4 is 7. And now I'm going to do 3. G of 3 is 10. Come over to f, find 10, and f of 10 is 8. Whoops. So essentially, my f of g of x then would be the set of points I just created. I started with 4 and got -2. Started with 2 and ended up with -5. Started with 9 and ended up with 7. And started with 3 and ended up with 8. Now I'll tell you, this is not something that gets used much in the real world, this kind of thing where you're doing it with the points, but this, the composition with functions, does all the time. But we'll talk more about that later. Now if I try to do g of f, this time I would be starting with the numbers that are in f, right? So let me erase all these arrows that I drew up here. So I'm going to start this. I'm going to say, starting with the x values that are in f this time, because I work from the inside out. G of f of 3. So f of 3 goes to -2. So then I would come over to G and say, where's -2? Well, there's no -2 x value in G. So that basically means this doesn't tell you what G does to -2. So it's undefined. Hasn't been defined by the function. Now, if that happens, you can stop, because that means this thing is undefined. All the points have to be able to go through like they did in my f of g in order for a function like this to be defined. All right, so that's the first part of these notes. Let's look at the second page. Now, this is basically the same sort of stuff, except we're using graphs. So g of f of 1 means g of f of 1. And I would plug 1 into f. Now, normally if I had an equation, I'd plug it in for the x's, or if I had like the set of points, I'd look for an x value of 1. I have a graph here. So instead, I want the y value on f of x, which is this graph, when x is 1. So when x is 1, it's that point right there. The y value is 3. So that means f of 1 is 3. And then I want to plug 3 into g. So I want to look at the graph of g. And I want to plug in 3. So I want the y value when x is 3. That would be -5. So go ahead and pause the video and try number 56. I will do it as well. G of -2 is 2. And f of 2 is -1. All right, so compositions can also come in multiples. Meaning basically you can chain them together. So for instance, this f of g of h of x, you can go ahead and start by writing it, in that other notation. Well, it won't erase now, which is awesome. So we'll just rewrite it. And again, we're going to work from the inside out. So we're going to take 2 and plug it into h. That's this. So that would be 1. And then take 1 and plug it into g. And then take -1 and plug it into f. So go ahead and pause the video and do number 60 and 61, and I will do them, and you can check your answers. So first, -4 will get plugged into f, and then that -2 will get plugged into h, and then that 9 gets plugged into g. And I'll do number 61 all in one fell swoop. And there you go.